Just to take you back to the familiar before I bring you forward into what's new. So back many years now, you learned how to graph lines. And the standard form of the equation for a line that you use to graph from, y equals mx plus b. And you learned this, and you learned it was called slope-intercept form of the line. There's two very important numbers here. These constants, m and b, when you had an equation of a line that you were supposed to graph, those were usually replaced by numbers, such as y equals 3/2 x plus 4. And these numbers here are parameters. These parameters told you something important about the line. They told you the slope of the line, and they told you the y-intercept of the line. Slope of the line told you whether the line went up or down, and how steep it was. The y-intercept, where does the line intercept or cross the y-axis? And I'm not going to waste your time graphing this line. I trust that you all learned how to do this way, way back in algebra or Common Core Math 1 for you youngsters out there. Okay. Later on, you went to the probably less familiar and comfortable to you, but graphing parabolas. And when you graphed a parabola, there were 3 parameters in the equation. So besides the x and y, the input variable and the output variable, there were 3 parameters that gave you some important information about the parabola that you were about to graph. It told you the coordinates of the vertex were h and k. And remember, A told you a couple things. If A was positive, your parabola opened upward. If A was negative, your parabola opened downwards. And then you learned bigger A was, the tighter or skinnier your parabola. I should say the bigger the absolute value of A. It's not the point right here as much as I wanted to get you in the right frame of mind here. We have a familiar equation. You know that's going to be a line. Once you're familiar with this, you know it's going to be a parabola. These letters other than x and y here, other than your input variable and your output variable, are the parameters. They tell you stuff about the line. How steep is the line? Where does the line cross the y-axis? Or they tell you important stuff about the parabola. Where is the vertex? Does it open up or down? Is it a tall, steep one? Or is it a wider parabola? Okay. Here's where we're headed in trigonometry. You know the basic shape of this is a line. These just told you how steep it was and where it hit the y-axis. You know the basic shape of this is a parabola. To graph the parabola, you need to locate the vertex and then get a couple points on either side to figure out where your U shape was going to go. As you saw from what you've done previously, the graph of sine the graph of sine of t and the graph of cosine of t make these waves that go on forever. And pretty much regardless of these parameters, unless you've got zeros for a, Unless you've got zeros for A or B, don't worry about that. But if we've got reasonable parameters in there, your graph is still going to be one of these wavy things that goes on forever. And the waves, again, they would continue on forever. You're just limited by how much paper you've got, how long your paper is to how many waves are going to fit on your graph and whatever. So we've got 4 parameters here. We've got A, B, C, and D. And some of these parameters are kind of easy to work with. And some of the parameters, in particular B and C, are a little bit more difficult. So I'm going to start giving you a few examples and sending you off to do a couple problems where we're not going to have to worry about B and C. Okay. If B is 1 times t, that 1's not really doing anything. And C is 0, adding 0 doesn't really do anything. So these simplify to f of t equals a sine of t, because again, 1 times t plus 0 is just t, plus d, and g of t equals a times the cosine of t plus d. So we'll work in the parameters b and c later, but we're taking this one step at a time. I don't want to throw all 4 parameters at you at once, so I'm going to worry about the easiest ones first, and then we'll build in the more difficult parameters later. So right now, we're just going to focus on the parameters A and D. Okay. I gave you an example to do on a worksheet that you're supposed to have done before you hit this video. And I wanted to look at the equation y equals 1/2 x minus 4 squared minus 6. And when I first had you do this, I deliberately chose what you might kind of automatically do, but some pretty bad values of x to plug into here. And if you plugged in the x values, you finish the table as I told you to. Here's what you got. When you plugged in -1, -1 minus 4 is -5. When I square that, I get 25. Half of that, 12.5, I'm going to make it as a decimal. I'm going to get 6.5 here. I don't need to go through all of these. You've already done them, I hope. And so I've got at 0, 2, at 1, and 2. Okay. Now, if you graph those points, you see I've got to let my x's go -1, 1, 2, 3. Okay, if you went to graph from here, -1, 6.5, I'm going to do this kind of quick, 0, 2, 1, negative 1.5, and 2, negative 4, I've got these 4 points. It's not a great set of 4 points from which to figure out what this graph looks like. So if you were trying to graph this for the first time, you're in an intermediate algebra class, you haven't quite learned how to graph parabolas yet, and all you knew to graph is, hey, if it's unfamiliar, plug in x's, get out some y's, get some points, play connect the dots. I'm not going to get a real good graph out of this. I'm not seeing a really good indication of where it is. Now, if you chose your x values that you were going to plug in a little bit more wisely, you would do better. Okay. You've done enough of this that you should know that a key point here is when x equals 4 and y equals negative 6. That's going to be the vertex of the parabola. So if instead I plugged in 4, again, 4 minus 4 is 0. All this becomes 0. I get out negative 6. I'm going to plug in 8. 8 minus 4 is 4. 4 squared is 16. Half of that is 8. I get out a 2. And this is bugging me. 4. Negative 6. 8. 8 minus 4 is 6. 8 minus 4 is 4. 4 squared is 16. That makes it 8. That makes it 2. And let me plug in one more here. No, I'm good here. All right, now, if I know this is the vertex, and I graph 4, negative 6, and I know it's supposed to be a parabola, and I've also got 8, 2. Let me extend this a little bit. 8, 2 here. And 0, 2. If these were the only 3 points I had, then I've got this one, and this one. Well, if I know it's supposed to be a parabola, and I've got the vertex, and I've got 1 point on either side, I've got a pretty good idea where I'm going. What's the point I'm trying to make here? If you just randomly throw in negative 1, 0, 1, 2 into your function, you might not get good points from which to figure out how to make your graph. But if you strategically pick your values, in this case I picked the vertex, and then I went a little bit to the left and a little bit to the left and a little bit to the right. Those didn't have to be the points I got, but I got numbers around the vertex, and I knew what the general shape was. All I knew was the vertex, 1 point on each wing, and I could sketch the graph. Okay, why does that matter with the graphs we're going to be doing? Well, remember that with my sine and cosine graphs, I get these waves. And so what I want to do is I want to strategically plug in values. So I know I'm going to get this kind of a wavy pattern. And what I really want to do to help play connect the dots is get the maxes and the minimums. These are the points I'm hoping to graph, and even the midpoints. And then knowing that the general shape is this kind of wavy thing, I don't need to get all the detail in between that you did on the last assignment when we graphed sine of t and cosine of t. If I know the general shape is a wavy thing, and I've got the midpoints, the high points, and the low points, I can draw a graph. So if I'm trying to graph this function, these green dots are the points I want. I don't want to just be plugging in random values and have a point here, a point here, a point here, a point here, and a point here. Because if all the information I've got is these black dots that look like this, I've got no idea where the hell this graph is going. But if I've got these key points and I know it's supposed to be a wave, then I've got that. Okay. Where do these key points happen? These key points happen at multiples of pi over 2. I'm going to throw this back up here for reference. Remember, my sine and cosine functions hit zeros or ones or negative ones when I hit one of these axes, every 90 degrees or every pi over 2 radians. So the values that I want to plug in when I'm going to graph are going to be multiples of pi over 2. Let's graph h of t equals 3 times the sine of t plus 2. So here, A is 3, D is 2, and again, I'm leaving B and C at 1 and 0, so they're not really doing anything. They're not getting in my way right now. These are the only two parameters that I'm using right now. Okay. Well, let me make a little table here, and in time you can probably learn to dispense with the table. But I'm going to have my values of t, and I'm going to use multiples of pi over 2, because I erased my circle, but those are where interesting things are happening, is on multiples of pi over 2. You know, I'm going to put 0 a little ways down here, and I'm going to put multiples of pi over 2, pi, 3 pi over 2, 2 pi. But here's going to be kind of where I'm going to start off at 0, and let me put a couple before it. Negative pi over 2, go backwards a little bit, and negative pi. And right now, all I'm going to find is sine of t. Am I still in the frame here? You might just want to keep this as reference here, okay? Sine, remember, is my vertical coordinate. So sine of 0, what's my vertical coordinate here? It's 0. At pi over 2, it's 1. At pi, my vertical coordinate's back to 0. At 3 pi over 2, I'm down here where it's negative 1. And at 2 pi, I'm back here where my vertical coordinate is 0. Okay, let's go backwards. Start at 0. If I go backward to negative pi over 2, my vertical coordinate's negative 1. And at negative pi, my vertical coordinate is 0. Now I'm going to take this one step at a time here. What happens to t? First it goes through the sine function. That's the least familiar to you, but not too bad. And again, I chose values every pi over 2 because that's where sine spits out a nice 0, 1, or negative 1. I'm not screwing around with any more 0.707s and 0.866s here. I chose these values so this would spit out a nice 0, 1, or negative 1. Now, if you have to do this in 2 steps, you can. What's 3 sine of t? Well, here's sine of t. I just multiply all these by 3. And then finally, here's what I'm after. I'm after 3 sine of t plus 2. Is the green showing up okay on the camera? Okay. So I'm going to add 2 to all of these and get 2, negative 1, 2, 5, 2, negative 1, and 2. So what's my graph look like? Biggest value for y is 5. Smallest is negative 1. So when I label my axes, let's see, I've got to go as high as 5 and as low as negative 1. So more room up top than below. I'm going to go 1, 2, 3, 4, 5. And negative 1 down here. And I've got these numbered every pi over 2. Or my key numbers are every pi over 2. But again, I don't need to put them all on here. If I put pi on here, my reader knows that this is half that distance. This is half pi. And this is 2 pi. This is 1.5 pi, or 3 pi over 2. Down here, I've got negative pi. And then where are my points? Let's go. I've got, starting here, I've got 0, 2. I've got pi over 2, 5. I've got pi, 2. I've got 3 pi over 2, negative 1. I've got 2 pi, 2. And going backwards here, I've got negative pi over 2, negative 1. And negative pi, 2. And I've got my wavy thing here. Okay. And again, I put my dots in the middles, on the high points, on the low points, because this would have been hard to graph if you had had random points all over the place. But once you know the shape what it looks like, and you know you've got your high points, your low points, and your middle points graphed, you can go ahead and graph that function. Okay. What I sometimes do when I'm going to sketch this is I'm going to put very lightly, I'm making this show up more than I normally would, a horizontal line there at my minimum, at my maximum, and at my midpoint. And I know I'm bouncing around in this envelope. Okay, I've got my maxes, got my mins. And if you want to double check, just plug in a few values and double check, and we look good.